So this is question 1 from G484 homework booklet. 1A is essentially pretty straightforward. It's just stating those definitions. You can see those on the screen. I'm not going to read those through. Key points are rate of change in there for the mark, and also for the pencil mark in A.E1. They were looking for momentum correctly spelt. They did allow equal instead of proportional, I think is the key thing, but trying to move on from F equals MA, so not looking for F equals MA. Part 2, the key points there was that the definition needs to refer to two bodies interacting. So we must have the two bodies interacting and the idea of equal and opposite force. If we go on to 1B, we've got this graph here. I've done a little bit of annotation on there. I ask you to estimate the area under the graph. Perhaps the most straightforward way of doing this is to simply count the squares. And in fact, the simplest way of doing that is to go to the technique of simply counting a square if it's bigger than half. So we get, I'm looking at the curved line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think we have got 11 and 12 there, 13, 14, 15, 16, 17, 18, 19, 20, 21 and 22. I'm going to ignore the ones at the top which are less than half, ignore the others that are less than half. So we've got 22 squares there. If we're working out the area, they are after an area in Newton seconds. So what we need to do then is to calculate what each square is, and simply we've got 500 newtons and 0.2 times 10 to the minus 3 seconds. So each square is 0.1 newton seconds, 22 squares, 0.1 newton seconds each, gets 2.2. Now you can see that as well as that, I've actually put on that triangle, because what you might have been tempted to do would be to put on a triangle which simply goes up to the peak of the graph. I hope you can see that if you did that, you'd end up with an awful lot of area around here and a lot of area there that wasn't under the triangle, but which is under the curve, so that would be a poor approximation. I've had a go at putting a triangle on here that perhaps gives a better approximation. Yes, we've got that missing area under the triangle, but I've got extra area there. Those two will balance off. If you did use that triangle, you'd end up with something in about the right area. And there was an allowance taken between 20 and 24. If you went for the triangle that simply peaked out at the top, you get at 1.68, and that scores one of the two marks. If we move on again, is to the physical quantity represented. So the area under a force time graph is simply the impulse. You'll notice again, we've got the pencil mark, so we do need that word spelt correctly, I-M-P-U-L-S-E. Into part 3, show the speed of the golf ball of that mass as it leaves the club is about 50 metres per second. The key point here is that the impulse that you've worked out is the change in momentum. Now I've also just written down here that the change in momentum is equal to the final momentum, and that's simply because the golf ball's starting from stationary. So delta mv, of course, would be mv minus mu, but u, therefore mu on this occasion is 0. So I've got the area we worked out is the mass times the final velocity, and that works through to that number there. Obviously you can carry any errors forward from the area that you had. Part 4 is very, very interesting. I think this was about question 1 on the first G484 question. And I think they were trying to make a point here. G484 is synoptic on, as is G485. Indeed, both of the A2 modules are synoptic on the AS course. That means they can ask anything from the AS course within the A2 modules. Usually that's small parts of questions and little bits, but this is really making the point. This is a classic bit of G481 projectile motion. So the things that, remember, you've always got to do with that is to split that into the vertical and the horizontal components. So they allowed, the first mark was for the first mark was for finding that initial vertical velocity. We've got a velocity of 50, we've got an angle of 42 degrees to the horizontal, and so it's sine 42, and that brings us out to that value for the initial vertical velocity. You've got a number of ways you can then use that to work out how long it's in the air. I think probably the easiest way is simply to use that the time to reach the maximum height would be that initial velocity divided by the acceleration, which gives you 3.41. The point there is that we're using v equals u plus at, with v, the final velocity, when it's at maximum height, is 0, and u is equal to 33.5 meters per second, and the acceleration is minus 9.81. So if you put those values in there, you'll end up with the 3.41 seconds. So the time to reach the ground is simply twice that time. It takes a certain amount of time to get to the maximum height, the same time to fall back down, so we can double that time to get the total amount of time in the air. And that's therefore the time that the golf ball's travelling for. And then if we put that together with the initial horizontal velocity, we had sine for the vertical velocity, cos for the horizontal velocity. We've got the angle to the horizontal, so it definitely is cos for the initial horizontal. That's the 37.2. Just a little thought there, if you're trying to work out which is sine, which is cos, because you're less than 45 degrees, the cos is going to be bigger, and you can in fact just work that out and see the cos is bigger. And if you imagine the component at 42 degrees to the horizontal, you would expect the horizontal component to be larger than the vertical component while we've got that, while we are below that 45 degrees. Once we've got that horizontal velocity, simply multiply it up by the time that we found for the ball being in the air, and we get that distance of 253 meters. The most obvious assumption is that there's no air resistance. The air resistance would both affect the time to reach the maximum height and therefore the time to reach the ground. It would also have impacts on the horizontal velocity during the flight. So for those two reasons, it would impact the total distance. So as I say, perhaps the easiest there is to simply say there's no air resistance. So that's the end of question 1 of G484. Hope that's some use.